Alrighty, we are still working on graphing quadratics in Vertex form. And so here's my parent function. You've seen this before for a quadratic. I know it's a quadratic because it's raised to the second power. And here it is kind of expanded out in vertex form. Y equals a x minus h quantity squared plus k. So you can see how we took this and they expanded it out. And that tells us that our vertex goes through 0, 0. So that's where that 1 is actually the lower spot for my vertex that opens up. And just kind of to get in the habit, a equals 1. Now, if we graph this, we can use Desmos. I like using a table of values just to kind of keep my math skills a little sharper than usual. And so if I pick some points to kind of see the behavior of my graph, so I'm going to pick a bunch of x values. I plug them into my function, and I find the corresponding y values. So when x is 0, y is 0. When x is 1, so as you can see, when x is 1, I get 1. When x is 2, I get 4. And x is 3, my value for y is 9. So I can try to graph these pretty points here. So there's my vertex, 0, 0. And when x is 1, y is 1. And when x is 2, y is 4. 4. When x is 3, y is 9. So there's the right side of my parabola. Whoa, that's not a pretty picture. And in case you haven't noticed with parabolas, wait, that one side does not reflect very well on the other side, does it? What should happen is my left side and my right side should be a mirror image. Take the left side, fold over on the right side, and I should be able to transfer those points. Now, thank goodness we have Desmos. They're a lot better at graphing. So here you can see our parent function. Y equals x squared. And there's my vertex, 0, 0. And when x is 2, y is supposed to be 4, if I can get that point to work. But if I were to split it right down the middle, the left side should be exactly like the right side, lay right over it, and that's what we call a reflection. Now let's go back and write down some more information that talks about the properties, the behaviors for the parent function y equals x squared. So in case you haven't noticed, if a is positive, the parabola opens up. If a is negative, the parabola opens down. If a is 1 or a negative 1, we kind of call that standard shape like you saw on Desmos, not at my pretty picture there. But if a is 1 or a negative 1, it's going to have that standard shape for a parabola. If a is a proper fraction, smaller than 1, then the parabola is going to be wider. So if it's less than 1, if a is less than 1, it actually makes it wider or compressed. If a is a nice whole number or larger than 1, then that parabola is actually going to be narrow when compared to my parent function. Alrighty, so stay tuned for some more examples. Please make sure you add all this info to your notes. It's very, very helpful in predicting the behavior of a quadratic and also helping you determine if you did it correctly. Bye.